Hi everybody, welcome and bienvenue, bienvenida. My name is Tim Stammers and I'm a senior analyst at 451 Research and we're an IT industry research firm. Today, 451 Research and Maxta are giving a joint webinar about hyper-converged storage. We'll give you an overview of the technology, market position, applications and technical aspects. Maxta is one of the leading vendors that are pioneering this technology. The slides of 451's content are my content, and I will be presenting them. But this will be interactive. So during the session, I'll be asking Maxta questions, and I'm guessing that they will probably chip in with comments on what I'm saying during the presentation. So I think now will be the time for Kieran to introduce himself, perhaps.
Thank you, Tim, and welcome everyone. This is Kiran Srinivasmurthy. I'm the Director for Products at Maxta, and I'll be helping Tim and we'll answer all the questions that you guys have during the webinar. Welcome again. Thank you.
Cool. So next slide, please. Excellent. So this is what we're going to be talking about over the next 30 minutes or so. Just how big is hyperconvergence as an industry change? Does it really deserve that somewhat overused word disruptive? What is the change? What are the applications? Why is it being used for those applications? And then finally, we're going to talk briefly about what to look for when you're comparing hyperconverged storage products. Next slide, please. Okay, there is absolutely no doubt about it. This is a new and important way. I was going to say in storage, but actually it's in infrastructure because it's about convergence. It is not the latest industry buzzword. Well, it is, but it's much more than the latest industry buzzword, and it's much more than a minor new technology or widget. And you don't have to take my word for it. You can see that comment up there. That is from the CEO of the top 5 storage OEM. You would certainly know the name. I'm not going to tell you who it was. Well, what's really interesting is that that CEO said it during a conversation about the challenges of flash and software-defined storage to legacy vendors. And his response was, hyperconvergence is the bigger threat. And the hyperconvergence wave has happened surprisingly quickly. It's it's blown up over the last 2 or 3 years. And there are a number of companies seeing very fast sales growth in this area. So obviously the question is, how big will the wave be? At the very least, it will be big enough to take a significant chunk of the market. I think anybody that says they know exactly how big it's going to be is kidding themselves. But like a lot of data center technologies, it can start probably at the low and mid-range, and it would take time to reach its full impact, probably several years. So, it's not going to replace a VMAX or Hitachi VSP or IBM Sharp DS1000 overnight. And it may never actually replace that very top end of storage. But it is going to have an impact. It will probably take its place in history as something on the same scale as the changes like mainframe to client server, or monolithic to modular storage, or the rise of the storage network or SAN, or even open source and Linux. I'm not saying it's going to be as big as those, but it's going to be on the same scale. It's going to become part of IT history, subsector infrastructure storage. It's definitely a big thing. And so the obvious question is why? Let's put some of the reasons up here. First of all, it's a simpler architecture, and not all, but most storage development in the history of IT has been about simplification and getting on top of complexity. Directly related to that simplicity, hyperconvergence changes the buyer from storage people to cloud and virtualization administrators. The storage OEMs don't have relationships with those cloud and virtualization people, and that's one of the reasons why it scares them. Another big reason is that some, but not all, hyperconverged storage products allow the customer to buy their own hardware. And that means the customer can shop around and they can even reuse existing gear. And importantly for the storage OEMs, it means that a big chunk of the customer's wallet or budget will no longer go to the storage OEM. It will go straight to the likes of Lenovo or the local reseller selling servers, or Western Digital selling disk drives. The storage OEMs now get cut out of the hardware side of the story. Next slide, please. Okay, so now we're going to enter the chapter where I talk about what hyperconverged storage actually is. I'm not going to spend a lot of time on this because I think a lot of people do already know it. But I do want to lay out the basic architectural change, and it is a basic, very basic foundational change. Next slide, please. So I'm going to talk about convergence, and the reason why I'm going to talk about convergence, which is different from hyperconvergence, is because there are big parallels, and it's part of the history. I'm sure everybody in this audience is familiar with converged products, such as the MPV blocks and NetApp FlexPod. Unlike hyperconvergence, convergence is not an architecture. A converged system is just a result of a service in which the vendor takes conventional storage, SAN, servers, and virtualization software, pre-integrates them, racks them, and cables them before they deliver them to your shop. So that's a lot like IKEA offering to assemble the furniture for you before they deliver it to your home. That's why I use the IKEA pictures on there. And the reason why this has become, and convergence has become a big thing. V-block sales are growing really fast. FlexPod sales, all the other OEMs followed EMC and NetApp into convergent services. It's because buyers want simplicity and faster deployment. Click to the next slide, please. Convergence is based on conventional standalone storage and SANs and servers. But meanwhile, there's been one constant in play all the time, and to use the cliche, that constant is change itself. So over the last 10 years, we've seen server virtualization change from a minority sport, mostly for dev test, into the dominant means of deploying applications, and we're still seeing server desktop virtualization grow. Then you've got Moore's law, which hasn't stopped, with server and desktop processors getting increasing in power. That has actually put a strain on storage systems. It's also given servers a little bit more power to actually act as storage controllers. And then the flash at the end, that's the least important of the three changes, but there are ways that hyperconvergence uses flash better than conventional standalone storage, and I'll come on to those. Okay, next slide, please. Okay, we should have a drum roll here because this is where I'm going to explain very quickly what hyperconverged architecture is. It's best to describe it in comparison to conventional storage. So on the left, we have conventional storage. You can see it. External shared storage, a storage network, linked to a number of servers via a 5-channel online scoping network. But that's also what converged systems are, as I was just saying. On the right is hyperconverged. The servers are still there, but now you're getting pooled and shared storage within. Can we go back? Thanks. Now we've got pooled and shared storage within those servers. The standalone storage and the SAN have gone, and that's pooled and shared storage within the servers gives you exactly the same services you had from standalone storage: snapshot, close, replication, SYN provisioning, you name it. And it's pooled. You add a server to the cluster, its internal storage is added to the pool, and the pool gets bigger. And how is all this achieved? It's achieved with software. That's why this architecture is also sometimes known as virtual SAN or server SAN. Hyperconvergence is the most common name for it, and there's an abbreviation that's starting to appear now, which is HCI, like VDI, HCI. That's quite a useful abbreviation because it's less of a mouthful. Whatever the name, the bottom line is that software replaces standalone storage and the storage network. And the servers can be physical, non-virtualized servers, but the huge majority of hyperconvergence is on virtualized servers. The software that you're using to do this can be a plug-in to the hypervisor, but much more commonly, it's just a VM that runs on each server. And yes, this, if you like the term, you can call this software-defined storage. And this is the product that really does fit that label, software-defined storage. But the most important thing to remember is that it can and often is based on low-cost commodity hardware. And that in some cases, it gives you total freedom to choose or reuse whatever hardware you want. So that's the foundation. Convergence was a step towards simplicity. Hyperconvergence is another much larger step. Next slide, please. So we talk about applications. So this is my chapter heading for applications. What is hyperconverged storage good for? Or if we want to mix some metaphors, if it's a wave, which courses will this horse run on? Next slide, please. Okay, this is where it's being used now in the enterprise. VDI was the killer beginning application for hyperconvergence. VDI usually needs dedicated hardware as a new project. Hyperconvergence allows you to build a pod-like module. You test a cluster of hyperconverged servers, server and storage, and you set up the right configuration to handle a set number of desktops with the performance level that's going to keep your end users happy. When you worked out that pod and scaled it and decided that's going to handle, let's say, 500 desktops, then you can roll out pod by pod. So hyperconvergence is really nice for that. Hyperconvergence also, the next very popular application has been remote offices and branch offices, robos. And it's for the obvious reason that there's far less hardware to install. So you've got a lot less gear to install in each office and a lot less gear to maintain. Dev test has also been popular because, as I'm going to get to later, hyperconverged storage gives you a lot of self-service and rapid provisioning benefits. And it's worth saying here that for the same reason, hyperconvergence has potential in the broader field of DevOps, agile code development, strong automation, and breaking down those organizational walls between developers, admin, ops, and security. But it's also being used for a range of mainstream applications, such as email, ERP, databases, SharePoint, you name it. And this is definitely happening, and there are enterprises replacing conventional storage with hyperconverged wholesale replacement. It's also good for disaster recovery, because again, that simplicity of installing in a second location. So if you're installing in a colo or one of your remote offices, it's very handy for that, because you're not installing so much gear. And finally, on this slide, analytics, because of the, I'm going to come on to this later, but hyperconvergence intrinsically promises higher performance because it's local storage within each server. I also put down here surveillance. That's a minor use case for hyperconvergence, but it's a good use case for hyperconvergence. But the biggest message to take from this slide is actually there's a very wide breadth of applications that hyperconvergence can and is being used for. It's not just VDI or dev test or robo. It's beginning to move into mainstream applications. And the next slide, please. Service providers. The growth of the cloud now means that people like me have to ask themselves, how well are you selling to service providers? Because there's so much gear going into service providers. The big hyperscale clouds, the Amazons, the Googles of this world, they were actually pioneers of this architecture. And this is an argument why hyperconvergence could go all the way up market and take over everything. The counter argument is that an Amazon mega data center, the operations in there are very different from those of an enterprise. But I still think it's a very interesting point. This architecture underpins the huge clouds that are dependent on low cost and reliability. While the Amazon and the Googles of this world, they build their own, we all know, they build their own systems. They don't buy any off-the-shelf stuff. There is an enormous number of smaller second-tier service providers who don't do that, and they are buying hyperconverged systems from companies such as our host today, Maxta. I know they've got service provider customers. They're buying, these second-tier service providers are buying into hyperconvergence. And they have like I said, they have an even stronger need for enterprises than enterprises to keep their costs down, to be able to scale easily and quickly provision services to customers. So the service provider usage is a big endorsement of the architecture. Next slide, please. Okay, I need to speed up a little bit here. Right, we're going to go a little bit further into the technology itself, and then we're going to look at the pros and cons compared to conventional standalone storage. And there are always pros and cons for every architecture. You can't get away from that in any engineering solution. So we'll start with the pros. First two bullet points are obvious: no SAN, less hardware, and no standalone storage. There are other less obvious advantages. You've got a fundamental performance benefit, which is that you're storing the data closer to the servers that need to access it, actually in the servers that need to access the data. It's a fundamental of IT architecture. The closer the data is to the CPU, the better the performance. So, for example, if putting a flash drive inside a hybrid or all-flash standalone storage system will boost your performance, using that flash drive inside the server itself will give you an even bigger boost, because you're cutting out the I/O latency of the storage network that sits in between the servers and the standalone storage. You've got synchronized servers and storage refreshes, doesn't need explaining. Hardware choice. There's a big spectrum across the hyperconvergence vendors. The wider the choice, the more the potential for customers to stick to their own preferred brand of servers or repurpose existing servers, and all the while avoid the hardware margins applied by legacy storage vendors. Okay, now the cons. And this is where I have a feeling Maxta is going to want to jump in and comment. If they don't, I'm going to ask some questions directly. So the most common objection raised by enterprises is that hyperconvergence involves something it's similar to lockstep scaling of CPU and DRAM with the storage capacity. So if you want to boost only your CPU and DRAM to get more performance, you need to add a server node, and that means you're going to have to add capacity that you didn't actually want to do. However, vendors are addressing this, hyperconverged vendors are addressing this issue. Then you've got lock into a hypervisor. This is going to get less important over time, but it is out there. We'll come back to that one later, I think. The coverage for the hypervisors is not yet universal, but it's not a big issue. Lose a node, lose all access to its storage. This is an architectural thing. If you lose a server or a node in the hyperconverged cluster goes down, the rest of that cluster cannot access the data stored on that server. And as a protection against this, there'll be copies of the same data stored on other servers or nodes in the cluster. But now the data is vulnerable until you redistribute the data across the cluster and make new copies. And that's a lot like a failure of a disk drive in a RAID set. You know, RAID 5, RAID 6 fails, a disk drive fails, you have to rebuild the RAID set. And the data redistribution in a hyperconverged cluster can take hours, and most importantly, it does affect performance. And this is an issue, and this is why the hyperconverged systems, they all have a default built in, which is if a node goes down, the rebuild doesn't start for 30 to 60 minutes, depending on their choice. Because you want to make sure, has that server really gone down, you want 30 to 60 minutes to check that minutes of the cable have been pulled out the back. And then the final con I've related here is again related to architecture. You can't use RAID 6, which unlike conventional storage, you can't use RAID 6, which gives you, what, 20, 30% overhead on capacity. To get the same level of protection in a hyperconverged setup, you need to distribute full copies of the data across the cluster. And that means you've got 100% or maybe even a 200% overhead on capacity. And for small robo deployments, that may not be an issue at all, because it keeps getting cheaper. By the way, Western Digital today are now 10 terabyte helium PMR drives. Right, so this is where I'm guessing that Kieran wants to step in. Because Kieran, I think you need to explain, how do you address some of those cons?
Sure, thanks, Tim. So let's just take the first one, right, around lockstep scaling of CPU and terabytes or capacity. The original hyperconverged models, yes, I mean, it was true. And even today, some of the vendors do lock customers in to say, you need to scale out by buying an appliance or buying a box, which has both CPU and capacity. So you are essentially forcing them to scale both of them at the same time. Maxta took a totally different approach. We wanted to preserve the flexibility of enabling customers to scale up compute resources and storage resources independently. If the customer needs compute resources, they can add more servers. They can add more memory to an existing system. They can also just add a blade server if they want to. And if it's capacity, they can replace an existing drive with a higher capacity drive. They can add more drives to an existing chassis with empty slots, or they can, as most of the others do, they can add another system which has both compute and capacity. So we addressed that lockstep scaling completely, and we provide full options to or full flexibility to our customers to scale independently. Just to address one of the other points around lose a node, lose all access to storage. Yes, I mean, if you lose a node, yes, the storage associated with that is not accessible. But what Maxta did was took a slightly different approach and said, okay, not every VMs need to be, and as Tim pointed out, we do make multiple copies to provide data access to those. But instead of saying all VMs on a particular cluster need to have 2 copies or need to have 3 copies or multiple 4 copies, Maxta took a slightly different approach and said, let's go look at an application and say what applications are more important. And for those, maybe customers want to make 3 copies and they want to rebuild those copies much sooner when nodes fail. So the idea behind it is, yes, although you lose access to storage, how can we make sure that rebuilds are done for virtual machines which are more important faster? And at the same time, how do we make sure that we throttle the rebuilds so that your primary IOs are not impacted? So that's the key, to make sure that you preserve your performance to the best, and you also make sure that things that are more important gets rebuilt sooner. That's the approach that we took.
That's fair enough.
Again, for the others are addressed similarly in different ways. And Tim, I'll hand it over to you to continue, and we'll take more questions later.
Okay, next slide, please. So I don't know what to call this. I called it system level benefit because this is actually quite separate, totally separate to the architecture itself. All of the features I've listed here can be part of standalone storage. And to be fair, there are examples of standalone storage from startup that do include all of these. They're not hyper-converged, but they have all of this. These features are simply very useful new generation storage features. They're far from universal in legacy storage. If you buy into hyper-converged storage, you're buying state-of-the-art, new generation, next gen, whatever you want to call it. You're getting all of this stuff because this is storage that was designed in the last 3 to 4 years. 3 to 4 years, not 15, 20 years ago. Storage services managed per VM or VM level. So by allowing storage services like snapshot frequency or replication, these hyperconverged systems almost universally allow stuff like that to be set at a VM level, and they eliminate the need to manage LUNs and RAID groups. You don't have to know about LUNs and RAID groups. That allows VM admins to handle their own storage. And by the way, this is what this vVols feature in VMware vSphere 6 is all about. It's an important feature. But the hyperconverged guys got there first, and their per VM management covers every flavor of virtualization across multiple hypervisors, and not just in the latest version of vSphere. And it is only the latest version of vSphere that gives you VM level management. So if you buy into hyperconverged storage, you get VM level management, which the industry, including VMware, acknowledges is a very useful feature. You get it across all hypervisors. You don't have to upgrade to vSphere 6 to get it. And it will help your VM admins self-serve their storage, manage their own storage. Hyperconverged systems were also designed from scratch to use flash alongside disk. Unlike legacy disk arrays, they haven't been retrofitted with sometimes clunky tiering systems. And those clunky tiering systems only move data periodically, and they need policies to be cited for each application. Instead, these hyperconverged state-of-the-art systems have near real-time tiering or caching built in to use their flash to its maximum. Inline dedupe and compression is not universal in hyperconverged products, but it's a damn sight more, excuse my language, it's a lot more common than it is in legacy standalone storage. So the bottom line on this slide is, separately to the architecture, you'll be buying into current next-gen, whatever you want to call it, current next-gen state-of-the-art storage. Next slide, please. Oh, yeah, I forgot that long clip. If we could go back to that, that's just a reminder, that grey box on the bottom. This is why those reasons, or those points that I put there, those are the reasons why hyperconverged storage changes the buyer to cloud and VMware admin and allows them to manage their own storage. Next slide, please. Okay, now we're going to look at some of the issues that are pertinent to hyperconvergence. I'm not going to talk about all the points on this slide. This is just a reminder of the classic parameters or issues for any type of data storage technology, whether it's digital, electronic, paper, or clay tablet. When the Sumerians started making these clay tablets, unconsciously they were thinking about all those things, even if there wasn't a Sumerian civil servant that actually issued an RFP. Next slide, please. So here is where I tried to lay out those 6 classic storage considerations and highlight the points that are relevant to hyperconvergence. So for scalability, the obvious question is, how many nodes has your hyperconverged vendor certified for the biggest possible cluster? That obviously affects how far you can go. And then, having established that, when you're considering capacity and perhaps IOPS performance, it might be worth bearing in mind the per node numbers, not the full system numbers. It's really a question of how much performance capacity can you add when you add a node. And Kieran has already talked about some of that. We talked about lockstep capacity in compute. There's a reminder here of that. I need to remind you about the VDI issue here. If you choose a hyperconverged product for VDI, can you link that VDI, that hyperconverged system, to external NAS? Because you want to store your user data on maybe you probably want to store your user data on external NAS and keep the desktop VMs in the hyperconverged system to simplify the backup. Next, I've got availability. Do you need synchronous or metro clustering? A lot of people do need that and they want that, and not all hyperconverged products offer this. Can we go back to thanks? Also, we talked about node failures, and you might want to apply the time-honored Twitch test during a demo, look your vendor in the eye, and while you let the yank a cable out, watch it do this face twitches. Environmental fit. Again, I'm going to highlight the fact that some products, there's a lot of variation between the software and hardware, the hardware freedom on this. Not only are there products out there like our host today, I'm quite happy to point out, I've got a very wide choice. You run on pretty much anything you want as long as it's x86. There are others that not only have they got a restricted list of servers, but they will require you've got to have some flash drives in there. That puts up your cost. And there are other specific hardware requirements of other boxes. And I think in the Maxta case, I'm going to come back to that software-defined issue. Maxta, our host today, they do seem to have a very wide, very open approach to what you can run your hardware on. That truly is software-defined. I haven't mentioned OpenStack. It's worth mentioning in environment. If you're going to go down the OpenStack route, you need to look at the ease of deployment and the integration with OpenStack. Ease of use. If you're going to deploy hyperconverter across multiple robos, you want to know how good is the centralized management. I've already talked about per VM level management. That can vary a bit, so you want to have a look at that in detail. How many parameters can you manage at a per VM level? What can you actually see on a per VM level? Finally, performance. So, the fact that hyperconvergence stores data locally on the server certainly boosts performance. But what happens when a VM moves from one server to another because you're doing a vMotion for load balancing or even just for maintenance? Does the data follow it to keep that local performance advantage? And it may do or it may not, depending on the hyperconverged product. So the question you need to ask the vendor is not, do you support vMotion and DRS or load balancing? Because they probably all will say yes to that, because they all do. The question is, how well do you support those functions? Does the system maintain performance by moving the data to keep it next to the VM that's accessing it? DD compression, we know that sounds useful, excuse me, very useful, but you need to watch for the performance impact on those, just like you do with any storage system with DG compression. There are performance impacts on some systems. Okay, final slide, I think. Okay, this is the slide I showed at the beginning of the presentation, example of the bricks and mortar architecture. Which one best represents hyperconvergence? Obviously enough, it's that one. That's a modular building. If I can go one step further, another click, and there is what I think represents it better, because that's the whole shooting match. It's a house, not just walls and roof. It's got doors and windows, plumb and wire it in, and it's ready to go. And I've got one more click. This is the overall promise of hyperconvergence. Lego-like simplicity, scale out, and flexibility, and design it the way you want to design it using your hardware. Next slide. I think that's my thank you slide. There it is, and the questions. So, Kieran, I'm going to hand it over to you for Q&A.
Sure. Thank you, Tim. And let me just pose a few questions to Tim to get his thoughts. And I'll start off with one, and then we will go back to the audience to see if they have any questions. Let me just start. So Tim, based on your research, I know you work with a lot of hyperconverged vendors, both, in addition to the traditional storage vendors. What are you seeing in terms of adoption within the community around hyperconvergence? Are they at a very introductory state in terms of looking at hyperconvergence? Have they moved up and said, okay, I'm okay to go deploy certain applications, or are they pretty much not yet even looking at hyperconvergence?
It's the old story of crossing the chasm, if everybody remembers that. I don't know how many people are aware of that. It's the old story of enthusiasts, people who know what they're doing will dive into it, will get into it before others do. It starts with new projects. That's why VDI has been a killer case for hyperconvergence. It also happens when there are server refreshes and storage refreshes and robo refreshes as well. But so it's not surprising, it's coming in at the corners. That's where it starts. Obviously, that's where it starts. You're looking for new gear, you've got a new project, you might consider hyperconvergence. But it's spreading already. There are multiple enterprises that have stepped straight, have gone the whole way into hyperconvergence and replaced entire conventional storage with hyperconverged storage. And that's why that CEO said this is a big challenge for us. Because with the exception of VMware, which isn't a storage OEM yet, and EMC had a corner case. Interesting, I should say. Interesting, but corner case hyperconverged product. You can't get this stuff from the storage OEMs at the moment. Oh, I'm sorry, I should mention HP. Yeah, they have one. But it's coming in at the corners, but it is now already happening in mainstream applications, and there are enterprises that have gone wholesale for hyperconvergence.
Thank you, Tim. I see a question from the audience which asks about, can you explain or can you repeat the vMotion performance impact point that you mentioned?
Sure.
Do you want to take the first pass?
I can do it, I don't mind.
Okay. Okay, I can definitely take a pass at it. So what Tim was identifying was, since you know that when one of the nodes fail, or when you move a VM over to a different node within that cluster, the data may not be on the same node where the VM is running. So you may want to look at if there is any performance degradation because of doing a vMotion across a different node. Or when a node fails and the VM moves over, the point was to look at what's the impact on the performance when these things happen during failure scenarios. Just to address from what Maxta does in those scenarios is, say, for example, in case of, as Tim pointed out, during a node failure. So what we essentially do is we allow users to set a threshold and also to set the rebuild priorities and how should we react in case of these failures. So in most scenarios, internally, if they use the default settings, we will always make sure that the primary I/O has very less impact as possible, and we reduce the priority of the processes that would rebuild the data across all other nodes within that cluster. So the idea was at least to go look at how we reduce the performance impact. Tim?
Yeah, I think you hit the nail on the head when you said the simple question is, ask your vendor, what happens to performance when I do a vMotion? When a VM moves from one server to another inside the cluster, what happens to performance? And then Kieran went on, and then the next question would be, and what happens to performance if a node failed? But that's the basic question. What is going to happen to performance when a VM moves from one server to another for load balancing or for maintenance? What will happen to performance?
Sure. So there is another question that came in that the question is, why should we trust hyperconvergence will solve previous issues with management and performance? I can take a first pass at it. I can take a first pass, and Tim can give at least a global view of what he thinks. So the idea of why should we trust hyperconvergence to solve these issues? There are two parts to this, right? One is, with hyperconvergence, one of the key aspects is it leverages SSDs or flash, as Tim pointed out, more efficiently than other traditional storage platforms. The idea of using flash to provide the acceleration for your writes, for your reads, and also for all the metadata that's that's part of this cluster will all be accelerated by using flash very efficiently. That's one reason to also show that, hey, performance can be accelerated with these tasks. The idea around simplifying management comes down to the fact that in a hyperconverged model, the object of management is a virtual machine, which users are very much accustomed to managing on a day-to-day basis. They would treat, say, the compute resources and the memory resources that they allocate to a VM as an aggregated pool of resource. The idea in hyperconvergence is to make storage look the same. It's a resource for a VM. You allocate a storage resource for a VM similar to your compute and your memory resource. So that's the whole concept, and that's the main reason being, hey, it's simple to manage, and we take into consideration the newer technologies more efficiently and at a much sooner pace to give you the performance. Tim, over to you.
Yeah, I mean it's a really good question because it's the fundamental question. The per VM management is hugely important. Elimination of installing a storage area network, maintaining that storage area network. And this is also the reason why some of the sales of hyper-converged storage have actually sidestepped the storage guys and gone straight to the VM admins or the CIO, which is scary, I know, for the storage guys, but that's what's been happening because it is simpler to manage because the VM admins look at it and go, yeah, we can run this. So yes, it's there. It's there. That's the management argument, and the performance. Yeah, it's not. I don't think performance is yeah, actually, hyperconverged architecture is faster because you are storing the data closer to the servers, and like Kieran said, these are ground-up designs. They're not retrofitted hybrid boxes. These were designed from scratch to be hybrid. So they're using real-time tiering. They're also using DG compression. So they're getting a lot more out of the flash than you would in a retrofitted legacy box.
Okay, I don't see any additional questions on the question Q&A session. So just one last question for Tim from my side. So Tim, do you also hear quite a bit from the customers that you talk to that in a hyper-converged model, do they look at having support for multiple hypervisors? Do they look at within the data center, what are you seeing in terms of people adopting multiple hypervisors and hyperconvergence requirement to support multiple hypervisors and so on? In general, the idea of you early on in the slide, you brought about hypervisor lock-in. I want to expand this to at least get your thoughts on how important and how much are you seeing in the field around multiple hypervisors being used?
I have some idea of what's going on. I can't say I have an entirely clear or detailed picture. From the top, we all know that VMware is Hyper-V and KVM and even Zen are increasing their share. So it's no longer a one world, a one hypervisor world. VMware is no longer the only game in town. When I say I'm not sure, quite clear on the exact details, because it depends on your setup. You might be happy to work. All the hyperconverged products support VMware, and all of the hyperconverged vendors, including Maxta, our host today, say we're designed with multiple hypervisors in mind. All of the hyperconverged vendors are working through the list. They started with VMware, they're adding the other hypervisors, and they will do it. They're adding them one every 9 months, one every year. So they're going to get there. They'll cover the list. I think the coverage is already pretty wide. How important is that to you? You've got to make sure it's ticked off. They are going to, if you've got plans to use more Hyper-V, if you buy into a hyperconverged product, are they going to support that and when? I don't think, that's why I don't think it's actually that big an issue. I know I raised it, but you've got to be sure that your particular product will support all the hypervisors you're going to use, and the answer is it's very likely. I mean, there are one or two products out there, I won't name them, but are obviously never going to support any hypervisor other than VMware, but the rest are all rolling it in. And it might be worth knowing, I don't know, Kieran, I mean, can you run mixed hypervisors on a Maxta setup?
So that's an interesting question. Can you run multiple hypervisors on the same cluster? So from a storage perspective, it would be agnostic to the hypervisor. The more important question would be, would customers be looking at running VMware and KVM as part of the same cluster, for example? Which also means, how do I move VMs across different nodes in the cluster? Becomes a lot more interesting kind of view. And also probably, as you mentioned, what OpenStack is probably going in that direction to say, look, this is a higher level orchestration layer. Now you can go provision different virtual machines on the storage platform, where the storage would be agnostic to the hypervisor that is being deployed. But there are more components within the infrastructure itself, and it's not just the storage that adds more complexity and interesting aspects into how do you deploy multiple VMs on the same storage.
Okie dokie, okie dokie. Do we have any other issues we need to touch on? You've already talked about whether all of your nodes need to be identical. And in your case, the answer is no. You can mix and match different types of hardware within a cluster.
Yep.
How about telling us what applications you think work best in hyperconverged?
So as you pointed out, Tim, what we early on saw people adopting hyperconvergence was for VDI and some branch offices and so on. But in the last year, and 2015 especially, and moving forward, where we are seeing customers move to is, oh, why can't I use traditional IT applications on hyperconvergence? I'm going to run my business critical applications on hyperconverged infrastructure. Applications like databases, all the way from Microsoft SQL databases to Oracle to MySQL, and also all the web services applications, middle tier applications, Exchange. So what we are seeing moving in what we saw in 2015 and moving forward is customers are more open to having their traditional IT applications being deployed on hyperconverged infrastructure.
Fair enough. And that's exactly what we've seen, which is it's now, it's doing the classic early adopters, knowledgeable people adopting it, and then it spreads into a wider and wider usage. And that's why it's that big threat to the OEM.
Yep. So Tim, I don't see any other questions come in from the audience. There is one more. Please explain Maxta is available as software that can be loaded on new or existing servers. So yeah, I can take that. Maxta does provide the ability for customers to use existing servers as well as they can use new servers, and they can even mix and match. Customers can start off with what they have, say for example, their older versions of a server model. I'm just going to take HP as an example. Say for example, the HP Gen 8 or the Gen 7 server range. And then as they move on, they can add newer models and retire the older ones. So this essentially provides customers with the ability to refresh their hardware on a rolling basis without any forklift in the hardware at all. So that's another major benefit that customers do get, wherein there is no forklift. You can take advantage of newer hardware on pretty much day zero, because it's a software model that we are coming up with that provides the capabilities. And then you could use your newer hardware and then just refresh. And at the same time, what Maxta provides is the ability to transfer these licenses. See, when in a traditional model, when you refresh your hardware, you pay for your when you refresh your storage, you pay for your hardware as well as your software. With Maxta, you buy your software once and you would never have to pay for your software again. You can continue to upgrade and refresh your hardware and have the perpetual license of your software being transferred to the newer hardware.
Another new model, another change in the times, and that's related to software-defined storage, an expression which I really don't like. It's part of the newer ways of buying IT. Great, Kieran. Any more questions?
No, I don't see any more questions from the audience. Oh, the moment I say that, I see another one. Also explain copying of data across all clusters. So there's a question around also explain copying of data across all clusters. How is license, and there's another one on how is license sold. So let me just address how explain around copying of data across all clusters. So what I'm assuming here is customers or the question relates to copying data across nodes within that cluster. So if we go that route, the idea with Maxta is for availability reasons, you need the data to be across multiple nodes within that cluster, right? So what Maxta does is provides the ability to configure this at a VM level granularity to say, hey, I have my VM. It's a very important virtual machine. I want to make 3 copies of this data. So what Maxta does at that time is make 3 copies of this data on 3 different servers. So if a server goes down, you still have 2 copies of your data. If 2 copies go down, you still have a copy of the data. So now it provides a better level of availability. That's the idea around copying across all nodes within that cluster, or copying across multiple nodes within that cluster. The next question is around how is license sold? Maxta is licensed based on raw capacity and the physical cores within the server that's managed by Maxta storage platform. The next question is, are we invited to the somebody is looking at the calendar invite. But anyway, I'll skip that. Yeah, definitely. You're invited for the luncheon at Maxta. Is this presentation being recorded? If yes, will it be available for later viewing? I believe this is recorded.
Yeah, Peter said he was recording this presentation. Yes, I believe Max's intention is to replay it quite definitely.
So the last question before we run out of time is it using VM agent to sense the heartbeat of the nodes or its own? So with Maxta, there are multiple aspects to this. From a storage point of view, we are using our own heartbeating mechanism to make sure that the other nodes that are delivering storage is up and running. And in addition to the normal VM heartbeat, which is also taking place to detect if an ESX node is online or offline. So there are both of those in the play when it comes to determining when the server is up or server is down.
Fine. Good answer, Kieran.
Yeah, there is one last question about what about monitoring. With Maxta, we provide different mechanisms to monitor and alert the users when things do not work as intended. Both hardware failures as well as software thresholds can be set. It can be we alert them through email. We also push the alerts to the cloud for Maxta support to proactively monitor those. So there are multiple ways in which customers can monitor the infrastructure as well as alerts when things do not work as intended.
Well, we're still showing a lot of attendees. Anybody wants to ask a question, fire away.
There is one more question that came in. Do nodes have to all exist physically in the same location? With Maxta, the answer is no. The short answer is no. You can spread the nodes across multiple locations, and Maxta will determine the location of these nodes at install time, and from there on, we know exactly where the nodes are. And when we create copies of this data, when you say, I want 2 copies, we make sure that those 2 copies do not reside on the same site or on the same data center or on the same location. It will be spread across different locations. So in case a data center fails, or it could be even within a data center, if you want, you can distribute across multiple racks. And if a rack fails, customers will still have access to the data. Okay, I don't see any other questions from the audience. And thanks, Tim, for presenting about hyperconvergence, educating the audience on hyperconvergence, the use cases for hyperconvergence, and the adoption of hyperconvergence, and most importantly, what to look for when deploying a hyperconverged infrastructure.
Great, no, thank you. I enjoyed that very much. Thank you very much, and thanks to the audience.
Thank you, everyone. And if you have additional questions, feel free to email Maxta. You could email at sales@maxta.com, and we will respond to your questions. You can request a demo. We will be very happy to show the product and we will very happy to do a POC of the product also with the customers. Thank you very much.
Thanks, everybody. Bye now.